Hi everyone, welcome to the third experiment in your physical science experience. Today we will find the density of liquids and solids. Now your experiment is divided into 4 different procedures. In procedure 1, we will determine the exact volume of the volumetric flask. In procedure 2, we are going to determine the density of an unknown liquid. In procedure 3, we are going to determine the density of an unknown solid. And in procedure 4, we are going to determine the density of various solid objects by measuring their mass and volume directly. The purpose of this procedure is to determine the exact volume of the volumetric flask. So first, I'm going to weigh the dry flask and stopper on the balance, and then I'm going to record the mass in table 28.3. The mass of the flask and stopper is 60.32 grams. The next thing I'm going to do, I'm going to determine the temperature of the water. So here I have a digital thermometer which I'm going to use to determine the temperature of the water. I'm going to stick the thermometer into the water and I'll keep it in there until the temperature stops changing, and at that point I will take the reading. Okay, so the temperature of the water is 24.0 degrees Celsius. In the next step, I am going to add water to the volumetric flask up to the mark. So if you look carefully, you will notice that there is a mark on the neck of the volumetric flask. I'll be adding water up to that mark, and then I will weigh and then I'll take the mass of the volumetric flask, stopper, and water. Now I'm going to use a drop-in pipette. So this is a drop-in pipette, and I'll use it to bring the water to the mark on the volumetric flask. All right, so you should make sure that the curved portion of the liquid is sitting exactly on the line. So I've brought the water to the mark, and now I'll take the mass of the flask, water, and stopper. The mass of the flask, water, and stopper is 159.84. And of course, that's 159.84 grams. Now I want to find the mass of the water in the flask. So earlier, I took the mass of flask and stopper, and then I took the mass of flask, stopper, and water. So to figure out the mass of the water, I am going to take the mass of flask and stopper from the mass of flask, stopper, and water. And I'm going to go ahead and calculate that now. So I have 159.84. I'm going to subtract 60.82 0.32, and the difference is 99.52. So the mass of the water in the flask is 99.52 grams. All right, so I have the density of water at different temperatures. I have the density of water at different temperatures in table 28.1. And our temperature was 24 degrees Celsius. So the density of water at that temperature is 0.99733. So I'm going to go ahead and record that density in my table. So the density of water at 24 degrees Celsius is 0.99733 grams per cubic centimeter. Once I know the mass of water and the density of water, I can use that to find the volume of water. Now, if you will follow me to the board, I'll show you that calculation. So now I'm going to show you how to find the volume of the flask, knowing the density and the mass. So we're going to start with the density equation. So we're starting with the density equation, D equals M over V. Now to find the volume, we're going to multiply both sides of the equation by V. So we're trying to get V by itself. So now we have V times D equals M. Now to get V by itself, you need to consider the operation that is being performed on V. It's being multiplied by D. So we need to divide both sides of the equation by D. So now we have that V equals M over D. So we're going to use the mass of the flask divided by the density, and that will give us the volume of the flask. So the mass of the flask was 99.52 grams, and the density of the flask is 0.99733 grams per cubic centimeter. So we're going to go ahead and use your calculators to figure out that mass. So in our calculators, the volume is going to be 99.52 divided by 0.99733, and the volume of our flask is 99.79 cubic centimeters. Okay, thank you. In procedure 2, we're going to determine the density of an unknown liquid. So we're going to use the flask we used previously. So we're going to empty the flask and dry it, and then I'm going to add an unknown liquid to the flask. So we already know the mass of the flask and stopper. So now I'm going to add an unknown liquid to the flask. So I'm going to go ahead and add an unknown liquid. I'm going to fill it to the mark. Okay, so as you can see, the bottom of the meniscus sits on the line. So I'm going to go ahead and take the mass of the flask, water, and stopper. And I'm going to go ahead and take the mass of the flask, unknown liquid, and stopper. And the mass of the flask, unknown liquid, and stopper is 166.70. 166.70 grams. Now we're going to calculate the mass of the unknown liquid. So first, we're going to use the volume that we just calculated. The volume of the unknown liquid, it's the same as before, and we calculated that to be 99.79. So we already know the volume of the unknown liquid, which is 99.79. And then we're also going to calculate the mass of the unknown liquid. And to do that, we will take the mass of the flask and stopper from the mass of flask, stopper, and unknown liquid. So the mass of the flask, stopper, and unknown liquid is 166.70, and the mass of the flask and stopper is 60.32. So I'm going to minus 60.32. And the mass of the unknown liquid is 106.38 grams. Now I'm going to calculate the density of the unknown liquid. Now density is mass over volume. So we can go to the board and do that calculation. Now we're going to find the density of the unknown solution using the direct method. So we have the mass of the solution, mass of the unknown solid, mass of unknown solid, and that's equal to 63.19 grams. And we are going to find the volume of the cylinder using the direct method. The volume of a cylinder is pi r squared times h. Pi as a value of 3.14, and we calculated r to be 0.95 centimeter. So we're going to go ahead and square that. And the height of the cylinder is 3.10 centimeter. So we're going to go ahead and do that calculation. So first I'm going to square 0.95. So 0.95 squared, and then I'm going to multiply by 3.14, and then I'll multiply by 3.10. So the volume of the cylinder is 8.8 cubic centimeter. Alright, so I have the mass and the volume of the cylinder. Now I need to calculate the density of the unknown solid. So the unknown solid and that's equal to mass over volume. So it's going to be the mass of the unknown solid over the volume of the unknown. The density of the unknown solid, and that's equal to the mass of the unknown solid. So the mass of the unknown solid over the volume of the unknown solid. And the mass of the unknown solid is 63.19 grams, and the volume is 8.8 cubic centimeter. The density is therefore, density of the unknown solid is therefore equal to 63.19 grams divided by 8.8. Okay, so this is supposed to be 8.80, and this is supposed to be 0.950. And so the density of the unknown solid is 7.18 grams per cubic centimeter. In the previous demonstration, I showed you how to find the density of the unknown cylinder using the direct method. Now I'm going to show you how to use the displacement method. So we had found the mass of the unknown solid to be 63.19. So I'm going to write that down in my data table 28.3. So the mass of the unknown solid is 63.19 grams. And now I'm going to put a certain volume of water in the graduated cylinder. So I'm going to put about 30 mLs of water in my graduated cylinder. And I'm going to record that volume. So I'm going to record the exact volume of water in my measuring cylinder. So here I have 31.9 cubic centimeters. So I have 31.9 cubic centimeters of water in the graduated cylinder. 31.9. And then I am going to add my, I'm going to add the unknown solid carefully without splashing to the water. And I'm going to note by how much I'm going to note the new volume. So the water in the cylinder has moved up to 40.9 cubic centimeters. So I'm going to go ahead and record 40.9 cubic centimeters. Now the volume of the solid is found by the displaced water method. So it's the previous reading minus the current reading. So it's a current reading minus the previous reading. So I'm going to take 31.9 from 40.9. So I'll just go ahead and say 40.9 minus 31.9. And that gives me 9.8 cubic centimeter. Now, I know the mass of the unknown solid, and I know the volume of the unknown solid. So the mass of the unknown solid is 63.19. So since density is mass over volume, so I'm going to say 63.19 divided by 9.0, and I have 7.02 grams per cubic centimeter. Now, the density from the unknown solid using the direct method is 7.18 grams per cubic centimeter. And when I use the displacement method, I have 7.02 grams per cubic centimeter. So we can see that even though the displacement method is said to be less accurate, these two values are fairly close. Fairly close. The purpose of procedure 4 is to determine the density of various solid objects by measuring their mass and volume directly. So first we have an aluminum cylinder, so we're going to be finding the density of the aluminum cylinder. Then we are going to find the density of a zinc cylinder, so we're going to find the density of a zinc cylinder, and we're going to, instead of an iron sphere, we're going to find the density of a steel sphere, and then we're going to find the density of a wooden block. So let us begin. So in order to find the density of any object, we need the mass of the object. So first we're going to take our aluminum cylinder and we're going to get the mass of the cylinder. The mass of the aluminum cylinder is 69.25. grams. Now, remember that the volume of a cylinder is given as pi. The volume of a cylinder is given as pi r squared. So pi r squared h. So it therefore means we need to find the radius of the cylinder plus its height. So first we're going to find the diameter of the cylinder, and then we will divide the diameter by 2 in order to get the radius. So this cylinder here is 1.90. So 1.90 is 3 significant figures, and I'm going to divide that by 2, and I will get 0.950. And then I'm going to take the height of this cylinder, and the height of the cylinder is 8.50. So the height of the cylinder is 8.50. And so the volume would be 0.95 squared times 3.14 times 8.50. So the volume of this cylinder is 24.1 cubic centimeter. So now I have the mass and volume of the cylinder. So now I can go ahead and calculate the density. So the mass is 69.25 grams. And the volume is 24.1 grams. So I have gotten a density of 2.87 grams per cubic centimeter. 2.87 grams per cubic centimeter. Now the table says that the accepted density of aluminum is 2.7, and we have found our density to be 2.87. So there's a minimum amount of error involved in this measurement. So 2.87, I think that's pretty close to 2.7. Next, we're going to find the density of the zinc cylinder. So again, I'm going to do the radius of the zinc cylinder. And the radius of the zinc cylinder is 0.95. So if the diameter is 1.90, then the radius here is going to be 0.950. And then we are going to take the height of that cylinder. The height of this cylinder again is 3.25. So the height of the cylinder is 3.25 centimeter. So we're going to go ahead and calculate the volume of the cylinder. So 3.14, that's pi, times 0.95, times 0.950 squared, times the height of the cylinder, which is 3.25, and I have calculated the volume to be 9.21 cubic centimeter. Now I'm going to record the mass of this cylinder, and the mass of the cylinder is 68.08. So now to figure out the density, I am going to say mass over volume. The volume is 9.21 cubic centimeter. The mass is 68.08. So 68.08 divided by 9.21. And I have 7.39 as the density of the zinc cylinder. The next thing that we're going to do, we're going to find the density of the stainless steel sphere. So let us go ahead and take the mass of our steel sphere. And the mass of our steel sphere is 66.15. Now the volume of the sphere is given as 4/3 pi r cubed. Now we're going to use a special measuring device to figure out the diameter of the sphere. So we're going to use what is known as a vernier caliper, and the vernier caliper has a main scale, and then it has a vernier scale which is found here, and we will find the diameter of the sphere using the caliper, and then from the diameter we can find the radius. Okay, so it's lining up at the 0.5. So here we have the reading from the vernier caliper to be 2.50 2.50 centimeter. So the diameter is 2.50 centimeter. That means the radius is going to be 1.25 centimeter. So the radius here is 1.25 centimeter. And then to find the volume of a sphere equals 4/3 pi r cubed. So if we put the value that we have for the radius into this equation, we will get the volume of a sphere. So we're going to say 4 divided by 3 times pi, which is 3.14, times 1.25, and then we're going to raise that to the third power, and we get a volume of 8.18. So the volume of the sphere is 8.18 cubic centimeter. Now we have the mass of the sphere to be 66.15 grams. So now we know the volume and we know the mass, so we can find the density. Density is mass over volume, so it's 66.15 divided by 8.18, and I've gotten 8.09 as the density of the steel sphere. So it's 8.09 grams per cubic centimeter. And finally, we're going to find the density of the wooden block. So here I have my wooden block, and I am going to weigh the wooden block to find the mass. So the mass of the wooden block is 39.07. And then I'm going to measure the dimensions of the wooden block. So I'm going to take the length of the wooden block, taking the length of the wooden block, and the length of this wooden block is 7.0 centimeter. The width of the wooden block so it's actually 7.00. The width of the wooden block is 5.10. And then the height of the wooden block is 1.75 centimeter. So now I know the dimensions of the wooden block. I will go ahead and calculate the volume. So the length is 7.00, the width is 5.10, and the height is 1.75, and the volume of the wooden block is 62.5 cubic centimeter. Now I have the mass and volume. I'll go ahead and calculate the density. So I have 62.5 cubic cent, sorry, the mass of the wooden block is 39.07, and the volume is equal to 62.5. So the volume of the wooden block is 0.625 grams per cubic centimeter. Now we've come to the end of our experiment, I just want to thank you for watching the video, and I will see you in class next week.